Welcome to AssignmentHelp, changing the way we learn. We revolutionize the educational landscape, offering a dynamic and personalized approach to help you excel in your academic journey. Let's move towards journey together. Here, we are going to explore about Microprocessor Fundamentals, including its architecture, operation, and memory organization. The solution you're looking for is on its way, so stay tuned, keep watching, and let's unravel the insights together. Our journey begins by understanding the bedrock of computing, any microprocessor fundamentals. Let's demystify microprocessors. These are integrated circuits playing the pivotal role of the central processing unit (CU) in computer systems. Understanding microprocessors is paramount for several reasons. Firstly, it forms the bedrock for comprehending computer architecture and programming. Secondly, it empowers us to use hardware resources efficiently and optimize software performance. Now that we've established a foundation in microprocessor fundamentals, our next destination is the exploration of microprocessor architecture. At the forefront is the arithmetic logic unit, which performs arithmetic and logical operations on data. Control unit decodes and executes instructions. Meanwhile, registers act as swift, temporary storage units, facilitating efficient data management. Buses are data pathways for transferring data between components, and memory stores instructions and data. Further, shifting our focus to data transfer in microprocessors, let's spotlight the bidirectional data bus, an essential player in ensuring smooth communication. It enables seamless two-way communication between the microprocessor and other components. It also facilitates both reading and writing of data, ensuring dynamic interaction. Moving on to read and write operations of microprocessors. In the intricate dance of microprocessors, read operations start with read enable activation, move to a specified memory address, and conclude with output enable signaling data readiness for a smooth transfer. Conversely, in write operations, write enable triggers the process, a memory address guides the data, and data write swiftly concludes with the information securely stored. Now, let's navigate through the intricate landscape of memory organization. Memory hierarchy comprises following components. First one is registers, which fastest but smallest. The next is cache, which is faster than RAM, coming to RAM, which stores instructions and data in moderate speed. Now, storage part, which has long-term effect but slow. There is unique address for each memory location. Last but not least, which is memory map, which defines how addresses are allocated. Let's unravel the fascinating world of the instruction cycle. In the microprocessor's world, the fetch, decode, execute loop is like a musical performance. It starts with fetch, where the control unit retrieves an instruction. Moving to decode, the instruction transforms into control signals. Then execute takes center stage, directing the microprocessor to perform the instruction. This rhythm repeats until the program concludes, creating a seamless flow of instructions. Hence, we conclude microprocessors as intricate powerhouses which are indispensable in computing. Understanding their fundamentals not only benefits, but is crucial for navigating the realms of computer architecture, programming intricacies, and staying attuned to technological advancements. It's the key to unlocking a deeper exploration of the digital landscape and harnessing the full potential of technology for the future. Seeking instant assignment help and homework assistance, our dedicated team is here to support you with quality guidance and resources, making academic success a shared journey. Connect with us for all your assignment needs.